Hello, I'm Lam Lam, an MPhil student in statistics. This video is an introduction to the workshop Causal Inference in Observational Studies. It consists of several sections: Introduction to Causal Inference, Estimation under Unconfoundedness, and Introduction to Workshop. And there are also some takeaways at the end of this video. Before we learn causal inference, we may ask a question: why do we need causal inference? Well, most questions in social and biomedical science are causal in nature. What is the effect of a treatment on the outcome? For example, a medical researcher may wish to find out whether a new drug is effective against a disease. An economist may be interested in uncovering the effect of a job training program on an individual's employment prospects. And also, a sociologist may be concerned about the effect of divorce on children's subsequent education. In the above setting, it is advantageous to know whether there is a treatment effect and also how much the effect is. Before answering these questions, let's introduce three types of variables. First is the outcome variable and the treatment variable, and also the covariates. Here, covariates are basically everything else that are possibly predictive of the outcome. Then, in a randomized experiment, the average treatment effect can be estimated by taking the difference between two average outcomes. One is the average of the outcomes of the treated group, and another one is the average of the outcomes of the control group. However, randomized experiments are generally not available. That is because in randomized experiments, individuals are randomly assigned to treatment groups. So let's consider the evaluation of the effect of smoking on lung cancer. If we want to conduct a randomized experiment in this case, we could simply flip a coin to decide whether to assign an individual 10 years of smoking. However, this can lead to ethical issues. So in real life, whether to participate in a program or not is often an individual-related choice due to some issues. Hence, we will focus on observational studies rather than those randomized experiments. However, this kind of observational data is relatively more difficult to analyze than randomized data. For example, when evaluating the effect of a job training, we may find that young people are more willing to participate in job training, and at the same time, young people have lower incomes. So, in this figure, the people in the treated group are younger in age and lower in the income. In this case, if we take the average of the income for the treated group and compare it with the average of the outcome in the control group, we may find that we get some negative values. Does it mean that such training programs are ineffective? The answer is not, because there is a covariate called age that affects both the treatment and the outcome. which makes it unclear whether the job training is a true cause of income increase. So here this covariate H is also a confounder, as it is a covariate that interacts with both treatment and outcome. To address this kind of problem, the idea of unconfoundedness, which adjusts for unconfoundedness, is needed. For example, in a job training program, we only compare the income of individuals within age groups, but not between age groups. And in this workshop, we will focus on the estimation of average treatment effects of programs or interventions in observational studies under unconfoundedness. And we will estimate the treatment effects using three estimators. Regression estimator, which first estimates the relationship between the covariate and the outcome for each treatment group by regression, and then the treatment effect can be easily estimated. Matching estimator, which match each treated unit to a selected number of controls. They are close to the treated unit in terms of the covariate, and estimate the treatment effect by averaging within match differences in the outcome. Mixed estimator, which combines matching and regression to provide a better estimation of the treatment effect. And finally, we will analyze two real-world data, medical data and job training data. Before ending this video, there are some takeaways. First, many studies are observational and they are not truly randomized. If you want to learn more about analyzing data from randomized experiments, you can watch this video by clicking this link. Second, covariates may interact with both treatment and outcome, which makes it difficult to tell if the treatment really has an effect. So in this workshop, you will learn how to deal with confoundedness in observational data, how to estimate the effect size, how to interpret the result, and also how to do all this using software R through hands-on practice with two real-world datasets. If you are interested in this workshop, register now. See you in class.